Dr. Martin, until Dr. Mohammed Shafik come up to the podium, I think you touched on an important aspect about the dry eyes, the sensitivity, the pain with no stain is also something that we're going to ask as a question later in the discussion after Dr. Mohammed Shafik starts his talk. Podium is yours, Doctor.
Good afternoon, everybody. Supposed to be the last talk in this session. And they asked me to talk about the art and science of wavefront. And I'm really a fan of wavefront, so I will take you a journey through time since the beginning, the very early beginning of wavefront. This is my financial disclosure. And back again to the 30s, when this genius man, Zernike, received the Nobel Prize for his genuine work to describe the light when it passes through huge telescopes and the distortion that light suffers. And he described that light passes into sheets instead of waves or instead of beams, and describes these distortions in a form of a polynomial equation, the ones that we know now as Zernike polynomials with a multifactorial equation that translated into the shapes that we know very well now. So we taught, or been taught as in the optics, that light travels in sheets or in waves, not in beams. But since that time until very recently, it took 70 years to be able, as ophthalmologists, to read these kinds of sheets by the introduction of the aberrometers in our armamentarium. And it was really something very strange to see how the patient is seeing and to see the retinal image, the true one, with its distortion, and to describe it in the same forms that Zernike gave to us 70 years ago. And of course, he owed for that the Nobel Prize. So from here, the wavefront science and art started to describe the difference between what's ideal, what had to be, and what's real, which is the wavefront, and the difference between them is the wavefront error that we read and we try to correct. What left from aberrometers, there are 4 types of aberrometer, but in practice, what left actually is the Hartmann-Shack, which is the analysis through the lenslet array, and the ray tracing aberrometer, which is tracing a beam when it goes and comes back, where when we send it to the retina, where it falls exactly on the retina. And this is much more, by the way, accurate than the Hartmann-Shack, and I will tell you the future of our ablation. So since that time, we knew that there is something beyond what we are correcting by glasses or even by normal refractive surgery. And Dr. Saadi described at the beginning very well the shapes. So we know now there is very higher things than the sphere and cylinder in form of these shapes that we know as the orders of the Zernike polynomials. And simply, our vision is a mix of all. You mix the cylinder, the sphere, and you put on them some coma, trefoil, because even the human eye is not perfect at all, full of aberrations. So this is a mix of all. And when we measure it, we measure actually the wavefront and how we see. Lucky enough and privileged enough, I was the one who bought the first machine in the Middle East in the year 2003. By that time, I was too young, and I was fascinated by the art and science. And I started from that time to treat my patients in a wavefront-guided ablation form. Well, 1 year after, Shalita made my day because he published this, and this is an iconic paper, how the wavefront aberrations interfere with our vision. And now, and by that time, since 2004, we know very well that wavefront or higher order aberrations are the main cause of the poor visual quality after refractive surgery. Because by that time, we had some patients who come in to us complaining, and the patient is seeing 6/6. But now, since that time, we knew that halos, glare, secondary image, and ghosting are due to the wavefront aberrations. And this is answered in part to the questions that was in between Dr. Amna and Dr. Sabah when she asked her what is the main cause of the unhappy patient. I think number 1 cause is the higher order aberration, and number 2 is the dry eye. So let me propose, this is a daughter of a friend of mine, and she was a young lady coming to me for refractive surgery, -2, -2.5, nothing special. This is a perfect pentacam. There is nothing special. So although I made for her this acquisition, the data acquisition, which shows coma, but I told myself, I mean, I will go for a wavefront optimized LASIK. And look at this. After a wavefront optimized LASIK, she came to me suffering from the distortion because I left behind the trifoil and the coma. So the only treatment to satisfy her was a wavefront guided redo to treat her coma and trefoil, and the aberrometer can generate this kind of a regular ablation profile to satisfy the patient. So to tell you how much important these are important, the higher order aberration, our treatment. So no one size fits all. I mean, we've learned that. Although those patients are the same, have the same or more or less spherical equivalent, but they are totally optically different, and you can't treat them by the same way. One size fits all does not fit our modern refractive surgery. Moreover, there is a stronger relation between the pupil size and the amount of astigmatism due to the higher order aberration. When you increase the pupil size, you increase the higher order aberration coming from the edges. So there is a nice equation. It's very difficult, by the way, but it explains why astigmatism increases. And this is another example. This patient has, by the aberrometer, this reading, -2.5 and -1.88 cylinder, while she is satisfied totally with the glasses, and the subjective and manifest refraction is only -1.5. If you ignore this third diopter, this makes the problem, because this third diopter is a translation of the summation of the higher order aberration. You should read it and treat it, because if you see here, the RMS value is 0.64, more than the normal. Another very important issue is the angle kappa. And again, I shouldn't stress on that. A large angle kappa has a solution in the wavefront guided ablation, because simply we measure the whole pupil entrance. You make a measurement of the whole pupil entrance, okay? And then you do an ablation profile related to the boundaries of the iris boundaries or the limbus, not related to the size of the pupil, and there is a compensation for the pupil centroid shift under the light of the laser. And this totally solves the great headache where to center our beam, because it is a debate between refractive surgery, where to center, on the vertex or on the center of the pupil. It is totally solved by a wavefront guided ablation profile, okay? So I'm not surprised when I gathered my patients and I published the longest, but this is, by the way, the longest follow-up study for a wavefront guided ablation. I published it in Journal of Refractive Surgery 2013, and I had 26% of my patients having vision more than 2016. So again, wavefront guided ablation approximates us from the dream that we can have a supervision, or we can extend the human vision beyond the 2020. We were taught in the physiology lessons that to see a letter E, you have to spare one cone between the white and the black. And actually, the letter 2020 had 3 cones in between. So what prohibits us from seeing better than 2020 in nature is that the aberration, and the human body or the human eye can see 28 if you can free our eyes from, and this is our dream, to have a supernormal vision after refractive surgery. One day we will achieve it, by the way. The year 2012 witnessed the introduction of the high definition aberrometers, like the eye design, and I have many of them. I will finish soon. So they have more resolution. They can reach 5 times in a 7mm pupil, and through them I was able to correct the irregular cornea, and I published again my first work on a pilot study of different types of irregular cornea. So what's new? Actually, what's new is the ray tracing guided ablation through this machine by IVIS technology. I'm looking forward to have one of those machines. This is simply an eye trace system to trace the wavefront and to generate out of it an eye trace dependent ablation profile that reads the refraction from all the surfaces of the cornea, even the posterior surface, and try to approximate it to what is called the ideal refraction. And by the way, the art and science of wavefront is still growing to make our vision better. Thank you very much.
Thank you very much, Dr. Mohammed Shafik, for a very informative lecture.